Hello and welcome to Master Maths Week 1 Video 3. This is Epsilon, and in this video we'll be going through our first introduction to series. So we'll start off with a little bit of theory. First of all, we've been covering sequences so far, and I'm sure by now you should know what a sequence is, but you have to be careful not to confuse this with the series. Okay, so let's just start off by writing a couple of differences between a sequence and a series. So a sequence is a set of numbers which are written in a particular order and are related to each other. In some way. Okay, so that's what a sequence is. It's a set of numbers. Let me just change colors a bit. It's a set of numbers which are written in a particular order and are related to each other. So an example of this could be something like 2, 4, 6, 8, 10, and so on. So this is just a set of numbers. It's a collection of numbers. By this, a set, as you'll see, as you continue with your mathematical careers, maybe into varsity, you'll cover a bit more on sets. But for now, just think of it as a collection of objects. So a sequence is just a collection of numbers that are written in a certain order and are related to each other. And we can see from this that, yes, the sequence is written in a very specific order, and all of these terms are related to each other because every term is just the previous term plus 2. This is 4 plus 2, 6 plus 2, and so on. So all of these numbers are related to each other, and they're just written in a particular order. They're just written out, basically. They're not being added together. They're not being subtracted from each other. They're just written out. Okay? So that's what a sequence is. But on the other hand, we have a series. So a series is very similar to this, but it's a sum of numbers which are written in a particular order, and I'm sure you can guess from here that the rest of this definition will be exactly the same as the other one. In a particular order and are related to each other in some way. So these definitions are very similar because we know that they're written in a particular order, that's still the same, and they're related to each other in some way. But the difference is here we have a sum of numbers instead of just a set of numbers or a collection of numbers. We have a sum. So an example, I'll use an example that's very similar to the one we did before. If we have 2 plus 4 plus 6 plus 8 plus 10 and so on. This is a series. And the reason we say it's a series is because, yes, it's numbers written in a particular order being related to each other. As you can see, they're obviously related to each other. But the difference here is that we are adding them up. It's a sum of numbers. It's a sum. Before, we just used our commas to separate the numbers because they were just separate from each other. They weren't being added, they weren't being subtracted, they weren't being multiplied with each other. They were just separate numbers on their own. But in this case, we're adding them together. So if you really think about it, we've actually covered, I wouldn't say covered, but you've seen series before. Since grade 1, you've been dealing with series basically. And the reason why I say that is because if you have something like 1 plus 2, that's a series. You're adding two numbers which are related to each other, because one is the other one added or increased by 1. So 2 will be 1 plus 1, right? So they are related to each other. You can make that relation between the two of them, and you're adding them together. So it's a series. It qualifies as a series. And this would obviously be 3. Another example, if you had, let's say, 1 plus 3 plus 5. Okay? We see that these numbers are related because they're separated by a difference of 2. And if we add all of them, we get 9. Okay? So these are series. And it's not the first time you're adding up numbers. So it's not the first time you're actually looking at series. So what you notice here is with series, we can add them up, obviously, and get an answer at the end. So this answer is the value of the series at a particular point. We represent that by Sn. It's the sum of the series for the first n terms. Okay? So let's actually go into a bit more detail with that by going into the types of series that we'll be covering this year. So going into a bit more detail, let's look at, let me change to green. Let's look at the first type of series, which are arithmetic series. Okay, so we know what arithmetic sequences look like. So we would expect arithmetic series to look very similar to these. So with arithmetic series, basically, you just have an arithmetic sequence that's being added up. That's basically it. So an example could be 3 plus 5, let's use a simple one, plus 7, and so on. So if we're told that this is an arithmetic series, it's an arithmetic series, right? What will be the next number that is being added up here? Obviously, it should be a 9, because the difference between all of these terms is just 2. So we know that the next one should be a 9. So with this, if we want to evaluate the sum of the series at any given point, let's say that we wanted to, let me just clean this up. Let's say that we wanted to find the value of the series at the second term. That's at this point here. What would we need to evaluate? We'd need to evaluate the sum of all of the numbers from the second term going backwards, right? Up until the first. So that would be equal to Sn. We represent that by Sn. And in this case, our n would be 2, because we're summing up the first 2 terms, which would be this 5 plus this 3. So S2 would be equal to 3 plus 5, which is 8. So let's try and actually expand this, write it out, and make it a bit longer so we can actually see how this behaves. Okay, so if we just write out a few more terms, our series looks like that. So let's look at this. What does S1 look like? What is S1 in the first place? What do we mean by S1? We mean the sum of all of the terms from S1 going backwards, right? But in this case, there are no other terms before S1. So that would just be equal to the first term, which is 3. Because you're just adding this and nothing on this side, because there's nothing to add. So it would just be 3, okay? Then what will S2 be equal to? S2 is the sum of all terms from the second term going backwards, right? So that would be 5 plus the term before it, which is 3, okay? Then what is S3? Let me just clean this up. S3 should obviously be from the third term going back. So that should be 7 plus 5 plus 3. And you continue this pattern with S4, 9 plus 7 plus 5 plus 3. S5 should be equal to 11 plus 9 plus 7 plus 5 plus 3. Alright, so we will continue and continue and continue for as long as we want to. Okay, so what if we wanted to find the sum of a whole bunch of these terms? Let's say that we wanted to find S100. Obviously, it would be very tedious and very boring for us to actually go and add up 100 of these terms. Who has the energy to do that in the first place? So it does become a bit useful for us to have a formula, a quick way of adding up these terms. So we do have a formula, luckily, and that formula looks like this. The sum of the first n terms of an arithmetic series, remember that we're dealing with arithmetic series here, is equal to n over 2 into 2a plus n minus 1 d. Okay, we won't go into the derivation of this formula since you've done that in class 100 times, I'm sure. You can just go and revise that to check where this formula comes from. But it's a very simple derivation. Okay, so this is the formula. This is what the formula looks like. So let's test it out. Okay, first of all, let's evaluate what these actually equal to. Okay, that's 3. I don't need to do anything there. Here we have 8. Here we have 15, that is. Here we have 24. Here we have 35. Okay, I hope all of those are correct. I'm just doing those off the top of my head, hoping that my mental math is still good. Okay, so let's actually test this formula out. Let's see what S2 is equal to. We'll just substitute 2 into n. We know the value of a, that's 3. N is 2. The difference between the terms is also 2. Okay? So 2 over 2 is 1. 2 times 3 is 6. 2 minus 1 is 1 times 2, which is 2. We get 8. Okay, so we have our 8 there. That looks correct. So let's check the next one. S3, we would have 3 over 2, just substituting into our formula here. We have 3 over 2 into 2 times. First term is 3 plus 3 minus 1 times 2. Okay, so we have 3 over 2 into 6. 3 minus 1, that's 2, times 2, 4. That will be equal to 3 over 2 times 10, which is just equal to 30 over 2, which is 15. Okay, so that's correct. So if we do continue just finding Sn for whatever n we want, we would see that this formula works. Let's try out our S100. even though I think I might need a calculator there, or we'll just leave it out and you guys will calculate what the actual numerical answer is. So we'll substitute 100 into 2 times a, which is 3, plus 100, or 100 minus 1, that is, times 2. Okay, so 100 over 2, that's 50, into 6, plus 99 times 2. Okay. (99 times 2), that is 180, plus 18, 198. So that's 50 into 6 plus 198, that is 204. So that is where I leave it up to you guys. You can punch that into a calculator and you get your answer for the sum of the first 100 terms. Okay, so that is how you find the sum of the first n terms of an arithmetic series. So that's basically all you need to know about arithmetic series. That's how they behave. Those are the properties, and these are very simple. So once you just know the formula, you know how to use it, then you should be fine. Okay, so let's move on to our next type of series, which are geometric series. Okay, so with geometric series, we basically have something that looks like this. We have, let me write this out in a very general form. You would have something that looks like this. We have A, our next term would be AR. And by the way, this is a sequence, geometric sequence. AR squared would be our next term. AR cubed, and so on. So this is what a normal geometric sequence looks like. And the reason why it looks like this, just write that out. Me highlight, this is a sequence. It's a sequence, not a series. So the reason why it looks like this is because remember that for each term, we go from the term before and we multiply by r. So A times r gives you AR. AR times another r will give you AR squared. AR squared times another r will give you, that's times r, will give you AR cubed. Okay, so the series continues like that. The sequence continues like that. So with a series, it's basically the same thing, but we're just adding them up. We're just adding them up. Okay? So that's what a geometric series looks like. Series. This one is a series because we're adding them up. Okay, so actually I think it would be useful for us to write something sort of like this for the arithmetic series as well, just to sort of show you how the general shape of an arithmetic series looks like. So with this one, we would have A as the first term. I'm writing out the sequence first. Then we would have A plus the difference, A plus 2 differences, A plus 3 differences. Oh, that's not, should not be a plus, we should have a comma there, and so on. So that's what the sequence looks like, arithmetic sequence. So with an arithmetic series, we add them up. We add them up. Okay, so that's what the series looks like. And the reason why it looks like this is because you start off with your first term A, you add D, remember your first difference? You get A plus D. You add your difference again, and you get A plus 2D. Then you add it again and get A plus 3D, and so on. Okay, so that's what the general shape of an arithmetic series looks like. Basically, the sequence and the series look very similar. It's just that instead of just writing commas for the series, you add, and for the sequence, you put commas. So that's the difference. But then in terms of the shape, it's all like A plus D, A plus 2D, A plus 3D, so on. Okay? So that's the general shape of an arithmetic series. All right, let's return back to our geometric series. These ones, as you'll see, these ones are a bit more interesting. So let's give an example. An example could be, let's just start off with a very simple one. Let's say that we have something like this. Oh, commas and pluses. Commas and pluses, don't mix them up. So we have 2 plus 4 plus 8 plus 16 plus 32 and so on. Very simple geometric series. And you should be able to tell by now that the value of r should be equal to 2. Okay? So we're multiplying by 2 to get the next term. Okay, so with this, let's see what our Sn would look like. Let's start off with S1. S1 is just 2. S2 is 2 plus 4. Let's write it out. That's 6. S3 is 2 plus 4 plus 8, which should be equal to, that is 14. That's 2 plus 4 plus 8 plus 16. That should be equal to 30, if I'm not mistaken. Okay, so it continues like that. All right, so that's what Sn looks like. Basically, it looks pretty much the same as the arithmetic. So in this case, we would also like to have a formula, right? Because we can't go and add up to find the sum of the first 1,000 terms, for example, unless you were doing it with some type of computer, but still, it's just not worth the effort. So we need to come up with a fast way of adding up these numbers, adding up these terms. And that quick way looks like this. Okay? That's the formula for the sum of the first n terms of a geometric series. And keep in mind, r should not be equal to 1. And why do we say this? Because if r is equal to 1, you get 1 minus 1 in the denominator, which is 0. And division by 0, that's a no-go area. We try and stay away from that as much as we can. Okay, so that's what the formula looks like. Let's test it out. Test it out with, let's just start from S2 because S1 is pretty obvious. S2, we substitute our value of A. We're looking at this series here from our example. Our A is first term, that's 2. Calculated our R to also be 2. N is 2 minus 1. Divided by R minus 1, that's 2 minus 1. Okay, so we have in the denominator we have 2 minus 1, which is 1. Dividing by 1 doesn't change anything, so we can just write 2 to 4 minus 1. That's 2 times 3, which is 6. Matches perfectly with what we have there. Okay, let's try S3. We have 2 to 2 cubed minus 1 divided by 2 minus 1. Okay, we have 2 into, that's 8, minus 1, 2 times 7, that's 14, which is a match. Okay, so that's what the formula looks like. That's how it works. So basically, that's how you apply the formula for the sum of a geometric series, and there's not much else to it. But I would like us to look at a certain example which might seem a bit odd, but I think we have seen something similar to this before. Okay, let's say that we have something like this. So we have 1 times negative 3. I'm writing out the sequence first of all, okay? So this is 1 times, then the next term is negative 3. Let's say the next term is 9, negative 27, then 81, and so on. Okay, so this might seem a bit strange, but it's not really, because it's a geometric series. It's a geometric sequence, sorry. Let me just write that out. It's a sequence. It's a geometric sequence. And what is the value of r here? Don't let the signs confuse you. The fact that there's a minus there, then here it's positive, then there's a minus again, then it's positive. If you just do your divisions, you'll see that we get r is equal to negative 3 over 1, or 9 over negative 3, or negative 27 over 9, or 81 over negative 27. And all of these give you r is equal to negative 3. So we have a negative r, right? What does the series for this look like? Okay, so the series will look like this. You add up the terms, remember? So we have 1 plus negative 3 plus 9 plus negative 27 plus 81, and so on. So if you just remove the brackets, what does this look like? We have 1 plus and minus is minus 3 plus 9 minus 27 plus 81, and so on. So what we see here is that we have a series, but it's not just subtracted by pluses. There are minuses here too. We have a minus, then a plus, then a minus again, then a plus. And if you continue this, you'll see that you'll have a minus, a plus, minus, a plus, minus, plus, so on and so on, interchanging between plus and minus. So does this mean that this isn't a series because it has minuses? No, it's still a series. It's just that we're adding up terms, but some of the terms are negative. And you'll see that if you write them out, if you just put it in brackets, we can just write it out with pluses only. So these two, our first series here, is the same as this series here. It's just that one is written without the brackets and the other is written with the brackets. So if you just remove the brackets, you'll see the minuses and pluses, minuses and pluses, minuses and pluses. But it's still a series because you're still adding up these numbers. You're adding up positive and negative terms. So just because it has pluses and minuses doesn't mean that it's not a series. It's still a series. So if let's say that wanted to calculate the sum of the first 4 terms of this series just to confirm that this really is a series. If you still do doubt it, let's write it out manually first. So the sum of the first 4 terms will be equal to 1 minus 3 plus 9 minus 27. Okay, so we need a bit of mental maths here. We have 1 minus 3, that's negative 2. Then 9 minus 27 should be negative 18. Okay, so we get negative 20. I hope my math is correct there. So if we just use the formula for this, let's see whether it gives us the same answer. So our A would be 1. Our R, remember our R, we calculated it to be negative 3 to the power 4 minus 1, because we're finding the sum of the first 4 terms. Our N is 4. Our R, negative 3 minus 1. Okay, so in the numerator we have 1 times something, which is just the same. The 1 doesn't do anything, we can ignore it. Then we have negative 3 to the power 4. That's 81 minus 1 divided by negative 4. Okay, so this is 80 divided by negative 4, which is negative 20. So we have a perfect match. So that just tells us that if the formula for calculating the sum of a series works for this sum of numbers here, then this should be a series because the formula works. So just because it looks a bit different doesn't mean that it's not a series. As long as it meets our little definition up there, as long as it's the sum of numbers which are written in a particular order and are related to each other in some way. And we say sum here. We don't say the sum of positive numbers only. It could be the sum of positive numbers, sum of negative numbers, sum of negative and positive numbers, as we saw in our example. It just has to be a sum. Then it will be a series. So don't be confused when you see series that have changing signs, that have pluses and minuses, or minuses only, because you might see some like that too. Just check whether that has a common ratio and whether it fits that definition that we saw. Then it qualifies to be a series. Okay, so there's no need for you to be confused. Alright, so those were our basics on series, geometric and arithmetic series. In our next video, we'll be covering the topic of convergence and divergence of geometric series. And that's actually one of the most interesting topics in sequences and series. So stay tuned for that, and we hope that you'll be with us soon. Thank you and goodbye.